Okay, moving on to bad takes. And is Ben Bikman becoming a regular on this section? Did we already talk about him or no? Is the first time?
This is the first time.
Oh, got it. Okay.
Maybe in our library of things to discuss more than one time.
Got it.
Yeah.
Okay. Ben Bikman says, new study further validates the view that hyperglycemia causes insulin resistance. One key to controlling metabolic health is controlling consumption of carbs to prevent constant spikes. So this is very important to understand in the low carb and very important to understand in the bioenergetic realm because it's a huge point of contention. So let's hear what Ben says.
With a problem as complicated as insulin resistance, it's no surprise that there are multiple causes. You know by now that I harp on glucose and insulin as causes of insulin resistance. This view is validated with a paper that was just published today in the journal Metabolism. And they found that by bumping up glucose levels in healthy adults, that within just 24 to 48 hours, the people had become demonstrably insulin resistant. This is so important because think about how most people eat. We have been told to eat multiple times per day, up to 6 times a day, and that the bulk of what we eat should be carbohydrate. This certainly means most people are spending almost every waking moment in a state of elevated glucose levels. As the study shows, elevated blood glucose causes insulin resistance.
That last statement just seems like a total stretch, but like what
We'll just wait till we get to the study.
Yeah.
It's just that like this is the most disingenuous take on this that I think is one of the most disingenuous takes that's possible, especially when you look at what was done with the study. Like to get to that extension and word things this type of way, this is like literally an advertisement. It's not I don't even know if he read the study like with the way that was presented. It's like very problematic, especially when you like the study was actually quite interesting. And like the things that the authors talk about, they have numerous studies in PubMed. After he referenced the study, I went and looked up a couple of the other studies. They look at the effects of insulinemia, hyperglucogonemia, the effect of hyperglycemia on beta cells and alpha cells, which produce insulin and glucagon. So there's a lot of really interesting research. But as far as like the idea that you can just eat, like if you're eating carbohydrates 3 times a day, that the blood sugar spikes that you have after that is causing insulin resistance based on this paper is not even close to what the paper is describing or like the reality of the paper. It's just if you read the paper, and I'm sure Jay, you're about to tell us about it.
You break down the paper for us, Jay.
Yeah.
Yeah, so the title is Chronic Physiologic Hyperglycemia Impairs Insulin-Mediated Suppression of Plasma Glucagon Concentration in Healthy Humans. And they did 2 different studies here, where essentially, and so the like in the conclusion, the first sentence is sustained 48 to 72 hour physiologic hyperglycemia caused whole body insulin resistance. So what they did in these 2 studies, which weren't exactly the same, but essentially what they did is they had people getting constant influx of glucose to their veins, like through a clamp.
Infusions. It was infused. They had an IV in there and they were infusing a glucose solution to keep blood glucose at a high level, a certain level.
For 48 to 72 hours straight.
Those people probably felt so good.
Definitely. So it's helpful. It's interesting to do for like parsing out physiological mechanisms. And we can talk about some of the details there, but has virtually nothing to do with a human eating food. Like even eating a high carb Western diet, like this is nothing to do with that. Like you're never going to see anything like this. I mean, even if you're insulin resistant and you're eating 6 meals a day that include carbohydrates, you're getting a spike that is maybe getting up 50 milligrams per deciliter, which is what they used, an increase of 50 milligrams per deciliter. And then it's going to come down. And it's not like if you're insulin resistant, it'll stay up for a bit longer, but it will come down. And you sleep for ideally at least 8 hours, where you're not constantly getting this constant glucose. You go, time between meals. Like it's not like it would be the equivalent of, I mean, not even, it's worse than, but it's like if somebody literally had like a massive bag of Skittles and just literally did not stop eating them for 48 to 72 hours straight.
If you go into the mechanisms too of the paper and you look at what the researchers' discussion is, first of all, they explicitly state in the paper, and there's multiple papers that these authors do, but throughout these papers, high free fatty acids causes insulin resistance, or high free fatty acids impairs insulin metabolism. So, and the reason I'm saying this is because I don't know, I know very minimal about this guy, Dr. Ben Bikman's work. I haven't read any of his stuff. I'm probably never going to read it after watching this post. Like, it's very unlikely, but I think he promotes like a high fat, low carb type of deal. But the authors are already recognizing that the high circulating free fatty acids are causing insulin resistance and adjustments in insulin metabolism and all this type of stuff. And they explicitly state that in the paper. So point number one is say this infusing glucose for 72 hours is causing insulin resistance. The solution is then not ever have glucose and run on free fatty acids to solve insulin resistance. And the researchers are clear about that. So like, regardless of whatever perspective is being implied with like, oh, we should eat a low carb diet, then even in the paper, that's not being discussed.
Yeah. I just want to point out, like, we're always saying like, oh, these papers are so stupid, blah, blah, blah. Like we happen to agree with the NEFA or the free fatty acids causing the problem, but we're not saying because they said it, therefore it's true. I just want to point that out.
Well, and the other thing I was going to point out before we were talking, so Ben Bikman is a PhD, right?
Yes.
If he is a PhD and he's writing papers, like, you can already see like he's reading this paper and that was his take on the paper, which is highly questionable if you start to go through the paper, especially because, again, as you mentioned, Jay, first of all, in what circumstance would you ever have, besides this, apparently, get a 72-hour infusion of glucose to keep your blood glucose levels elevated 50 milligrams per deciliter over their baseline? Never. There's no way, even if you ate in the nighttime, you would still have gaps between all of your meals. Like, this is not something that could occur overall. Like, this wouldn't happen. So there's that piece. That's the first piece that I think, like, this context is irrelevant to the conversation around glucose being a cause of diabetes. Now, this is very helpful. This type of paper is helpful in understanding what is going on in people who are dealing with hyperglycemia and dealing with impaired glucose tolerance and things along those lines. And so there's actually a lot of interesting components, because I read some of these other authors' papers after I saw this, just because I got interested in after I read this paper, I got interested in some of the other things that they were talking about. And so there's some really interesting things that they talk about. There's some quotes here from some of the other papers. They have another paper. It's called Effect of Mild Physiologic Hyperglycemia on Insulin Secretion, Insulin Clearance, and Insulin Sensitivity in Healthy Glucose Tolerant Subjects. So the first thing that they talk about, they say beta cell dysfunction and insulin resistance in liver and muscle represent the core pathophysiologic defects in type 2 diabetes mellitus. So the first thing that I want to discuss here is that a lot of people think of insulin resistance like this whole body entire thing, but insulin's major job is to push carbohydrate into fat, muscle, and liver for glycogen storage and for future stores. The rest of the body doesn't use the GLUT4 receptor to absorb glucose. So that first piece, I think, is really important, that the accesses these types of things. It's overall, and for the picture, as we get into the rest. The other thing that they start to talk about is that persistent hyperglycemia in studies has been shown to impair insulin-mediated glucose disposal in humans and induce beta cell dysfunction in animal models. Prolonged exposure of human islets, so these are the areas where insulin is produced, to hyperglycemia decreases insulin content and impairs secretion. So what I'm going to get to and what I'm talking about, what they kind of show in this paper, is that the cells that produce insulin, the beta cells, and then also the cells that are responding to insulin, can only produce so much insulin in a given amount of time, the beta cells, and can only respond to insulin so much in a given amount of time. So if you chronically infuse glucose continuously so that you always need insulin, what happens is they actually caused fatigue to the beta cells. So the pancreas literally was fatigued from having this insulin, this glucose being infused all the time. And basically the problem was in normal people, the beta cells produce a certain amount of insulin, proinsulin, and they have a pool of this. They kind of like a storage there. And when you have a meal, it has this store that it can release. But if you have chronic hyperglycemia, in this circumstance, you're infusing glucose all the time for 72 hours straight. What winds up happening is that the cells have to make that proinsulin that turns into insulin on the fly. And that actually starts to become stressful for the cell to some extent because there's only so much it can do in a given amount of time. And so this is helpful to understand what's going on in people with type 2 diabetes. The other thing that they talk about is that the people became hyperinsulinemic in these types of studies because the ability of the cells to actually degrade the insulin over time became impaired, because the way the insulin is degraded is it attaches to the receptor and it's internalized in the cell and then it's degraded. But if you're constantly flooding with glucose all the time, then the insulin doesn't get fully cleared. And so then you get this hyperinsulinemia state going on overall. So what this is showing you is like this study, these types of studies aren't bad studies. These studies are showing us what's going on in people who are dealing with chronically elevated blood glucose levels, which they have another paper talking about is generally a function of glucagon. So it's glucagon continuously releasing the gluconeogenesis or inducing gluconeogenesis, promoting that blood glucose output. And then with this chronic glucose response, you're having a problem with the beta cells and being able to keep up with insulin production and the cells responding to it. And so the dysfunction isn't just carbohydrate causing this problem. It's like what's going on with all the regulatory pathways. They go on to say here, in response to an acute hyperglycemic stimulus, insulin/C-peptide, which is a component of proinsulin, are secreted from a readily releasable pool. However, after prolonged exposure to glucose, insulin secretion is more dependent on release of recently synthesized proinsulin. The present results are compatible with a defect in the beta cell's ability to respond to an acute hyperglycemic stimulus by enhanced secretion of newly formed insulin. So basically at a certain threshold, like the cells cannot keep up. And the way the researchers in this study actually determined that these people had become insulin resistant, at least in some of the other studies, was after they ran the 48-hour or 72 hours of continuously infused glucose, they exposed them to a hyperglycemic clamp. And what they did was they increased blood glucose levels to something like 300 milligrams per deciliter after they were chronically exposed to this the 50 milligram per deciliter insulin for 48 or 72 hours. And then they saw what the body's response was. And basically what they were showing was that at that point, like the cell's ability to muster up insulin production from the beta cells was impaired to some extent. And so was insulin sensitivity. That's where they actually saw the problem initially, was in this hyperglycemic clamp. And that's infusing tons of glucose into the bloodstream overall. So I think these papers are really interesting. They're really helpful to show what's going on in the type 2 diabetic state. But this is telling us absolutely nothing about eating carbohydrate on a regular basis and how the beta cells and alpha cells are responding in a normal person's circumstance. And then to promote that eating carbohydrate because it raises sugar acutely is causing this problem is laughable if you read this paper, because if you're seeing the mechanisms by which they're describing the problem, where the beta cells, they have this pool of insulin that's being released, and that if you chronically have hyperglycemia, it's not responding. That doesn't happen in a normal context. Once you have your meal, you have your insulin response to your meal, and then things come back down to baseline. And throughout that time, your cells will be able to resynthesize insulin or whatever the deal is, and then push it out for the next meal and whatnot. So that's more of it. That's what they're saying is going on here. And I think I don't know if you read the paper or not, but if you start to go through it, those are the things that you start to see.
I think it's important to mention that what they did here was they're trying to create a deranged metabolic state of insulin resistance in a very short period of time. This has nothing to do with what actually causes this state in a normal physiologic context. And the other thing is, it's not like they cause these people to become diabetic. Like they aren't in a permanently insulin resistant state or semi-permanent, like somebody who is actually insulin resistant. I'm sure if they then gave them 24 hours of normal eating and then did the glucose tolerance test, they would have been fine. What they're inducing here is a temporary state of insulin resistance, and that has nothing to do with what causes it in a pathological state. And so if you want to think of things that will cause this sort of insulin resistance, a ketogenic diet, a low carb diet will do it easily. And people know this. I'm sure Ben Bikman knows this, that if you give somebody who's on a ketogenic diet an oral glucose tolerance test, they'll perform terribly. They're extremely insulin resistant. It's not because keto causes type 2 diabetes. You can make that argument maybe super long term through various indirect mechanisms, but we're not trying to say like, yeah, most people have type 2 diabetes got it from being on a ketogenic diet. Trying to use this sort of study design as a way to support that certain dietary habits have anything to or will cause insulin resistance is absolutely ridiculous. And again, like I think the ketogenic diet is a parallel mechanism. The other thing too is his whole stance, from what I understand, as far as the underlying situation of insulin resistance, is essentially that the cells have continued to get the glucose and they've continued to get the insulin spikes, and so they've gotten tired and fatigued and they no longer respond to insulin. And that has very little to what's going on here, or what we would say really causes insulin resistance, which instead has to do with the cellular utilization of glucose being reduced, which then impairs glucose uptake at the cell, causes hyperglycemia, causes hyperglucanemia, and also prevents insulin's actions in many ways. And any sort of overfeeding where you fully saturate all the tissues with glucose, or I guess also fats if you're on a super low fat diet or low carb diet, those will cause states of insulin resistance, but this is not pathological insulin resistance like type 2 diabetes where the cells can't use the glucose. They're just temporarily overloaded with it. In this case, it took 48 to 72 hours of infusion of glucose to cause that. But as I was saying, this is a temporary thing that would immediately go away as soon as they stop getting huge floods of glucose. It's like, yeah, if you ate 8,000 calories a day of carbohydrates and then took a glucose tolerance test, assuming that you're not like Michael Phelps and you're really active, you're just sitting around, and then you took an oral glucose tolerance test, of course you're going to perform poorly. What do you think is going to happen physiologically to the glucose? It's absolutely ridiculous to draw any sort of conclusion here that this has anything to do with normal human feeding in any way, let alone normal carbohydrate intake.
The main thing to look at with all this type of stuff is what is going on with the metabolism at the cell, and understanding like what is insulin's purpose. Like kind of the reason I framed it in the beginning is like insulin is pushing the carbohydrate into other tissues for storage. The other tissues are going to be using the carbohydrate whether you have insulin or not. So it's really like, it's almost like, in the way I see this too is like if you were under starvation or if you were in a caloric deficit or whatever the deal is, the tissues that you start to break down are fat and muscle. And then the tissues that are also responding to insulin are the tissue is fat and muscle to a large extent, or liver, which has glycogen. And liver also has the glycogen broke down. So these are considered the overflow, the excess tissues to some extent by the body. So in states where you don't have enough substrate, you break down muscle tissue. You don't break down muscle glycogen, but you break down muscle proteins in order to create gluconeogenesis or to run gluconeogenesis. And you'll break down fat tissue for fatty acids. When you have enough of substrate available, you will release, or you have a decent carbohydrate intake, you'll release the insulin, and the insulin will push to these tissues to increase your stores. So you're like looking at these things. It's like, of course, if you have a circumstance where you're running tons and tons of substrate into the system, there has to be a point where the system's like, okay, like let me catch up to what we're doing overall. So the question is really what's going on at the cells in response to these types of things. What is going on metabolically? And I think this does not answer that question at the cells. Maybe it helps us understand what's going on with the alpha cells and the beta cells of the pancreas in response to these altered signals. But what's initially causing the hyperglycemia for people who are dealing with the type 2 diabetes or the metabolic dysfunction, I think is actually the metabolic dysfunction peripherally first. That would be my argument. And then the system is getting deranged after that through this kind of access. So this study doesn't answer that question. The study doesn't directly push into that and showing that like the cells are having a metabolic issue directly overall. It's like if we create like hyperglycemia for an extended period of time, then we cause problems. Like, yes, but it's like for a diabetic, what is actually causing that hyperglycemia for extended periods of time for them? And I would argue that it's likely stress hormones, because those are the things that are doing that, and alter metabolism peripherally.
Yeah. And just to add in one other thing, as far as the methods of this sort of study is, if you're forcing hyperglycemia through a clamp and through infusion, you are inherently needing to keep a constant rate above what the tissues are utilizing. Because otherwise, as soon as you get up to 150 milligrams per deciliter, it'll go back down. So you have to keep pumping more and more glucose beyond what the tissues are metabolizing. like you are forcing that sort of situation. It's massive amounts of glucose that, again, to also maintain that for 48 to 72 hours. It's like, yeah, of course, this is going to cause insulin resistance by oral glucose tolerance tests. It has nothing to do with the physiology of insulin resistance, what causes it, and what's going on dietarily for somebody that's causing this state.
If you enjoyed that clip, you'll definitely want to download the free Energy Balance Food Guide. The Energy Balance Food Guide will help you determine exactly what to eat to optimally support your metabolism and help you lose weight, improve your digestion, get amazing sleep, boost your energy, and so much more. The food guide makes it extremely easy to get started with a bioenergetic approach to optimizing your health. So head over to jfeldmanwellness.com/guide to download your free Energy Balance Food Guide.